Here we'll start to discuss on the principal strain. Earlier lecture we have discussed on the principal stress. The principal stress is a stress which acts on a principal plane where the shear stress is 0. Similarly, in the principal strain also same definition is there. The principal strain is a strain which acts on a principal plane where the shear strain is 0. So shear strain, that we denote the shear strain as gamma. So gamma is 0. When the gamma is 0 on any machine component or element, then that plane is called the principal plane, and in that plane the strain which act called the principal strain. Various formulas are there to solve the problem related to the principal strain, and that formula will discuss one by one. Here in this principal strain, the normal or the major principal strain is denoted by the epsilon 1, which is nothing but the replaced by the sigma 1. In the principal stress condition, the major principal stress was denoted sigma 1 in earlier lecture what we have discussed. Similarly, that is replaced by the epsilon 1, sigma 2 here replaced by the epsilon 2, and the CL stress tau xy replaced by the gamma xy by 2. This is only the conditions, and we just put the formula we have studied in the principal stress. In that formula we just replace the sigma 1 as a epsilon 1, sigma 2 as epsilon 2, and tau xy as a gamma xy by 2. All the formulas are same, and if you replace by these things, the formula will be applicable for the principal strain. Similarly, the major principal strain is denoted by sigma epsilon 1, and then it is denoted by this epsilon x plus epsilon y by 2 plus root under the epsilon x minus epsilon y by 2 whole square plus gamma xy by 2 whole square. This is the formula for the major principal strain. The minor principal strain is this by 2 minus root under epsilon x epsilon y by 2 whole square plus gamma xy by 2 whole square. This is the formula for the minor principal strain. The location next is location of principal plane. For the principal strain can be denoted by 10 to alpha. Alpha is nothing but the angle of the principal plane, and here this we can write 2, and tau xy is replaced by gamma xy by 2 upon epsilon x minus epsilon y. If we cut this 2, it would be gamma xy upon epsilon x minus epsilon y. This is the formula for the location of principal plane. From this we can get the alpha, and alpha is nothing but the angle of major principal plane. Similarly, the alpha 1 we can find out from the alpha plus 90 degree. That is nothing but the angle of minor principal plane. Minor principal plane. Now next one is maximum shear plane. Shear plane. The maximum shear plane can be found out by beta is nothing but alpha plus 45 degree, and the beta 1 is nothing but beta plus 90 degree. Same. Maximum shear strain. Maximum shear strain can be calculated with this formula by 2 is nothing but epsilon x minus epsilon 2 by 2. So gamma max is equal to epsilon 1 minus epsilon 2. So this is the formula for maximum shear strain for 2D, two-dimensional. So this is the formula of the maximum shear strain for two-dimensional, that is gamma max by 2 equal to epsilon 1 minus epsilon 2 by 2. That is nothing but gamma max equal to epsilon 1 minus epsilon 2. So these are the formula for the principal strain, and with the help of this formula we can solve the problem of the principal strain. And in the next lecture we will solve some of the numerical problems related to the principal strain. Till then, thank you.